Morning students. In previous video we discussed about 16th group elements. Now we are discussing groups. Till we completed 16 groups, 15th group and 16th group. Now next group is 17th group elements. The elements which are present in 17th group are fluorine, chlorine, bromine, iodine and astatine. These are the symbols F, Cl, Br, I, At, and these are the respective atomic numbers of the elements, and this is the electronic configuration of respective elements. If you observe the electronic configuration, that means outer electronic configuration, in this case 2s2 2p5, in this case 3s2 3p5, in this case 4s2, this is not 4p2 4p5, 5s2 5p5. Here 6s2 6p5, 6s2 is there, just note it, 6s2 6p5. From all these points we can say that the general electronic configuration of 17th group elements is ns2 np5. Based on outer electronic configuration we can say that general electronic configuration, that is ns2 np5. These are also called halogens. These 17th group elements are also called halogens because they are present in C. That is why they are called halogens. In Greek, halo means C. Next, these are also called 7A group elements. Next, these are the minerals of 17th group elements. Minerals means natural form of elements in the earth crust. Fluors, for the formula for that is CaF2, fluoroctite 3Ca3 PO4 twice CaF2, cryolite Na3 NaLF6, and carnallite KCl MgCl2 6H2O, chloropatite 3Ca2 PO4 twice CaCl2 3Ca3, not Ca2 here, just note it, 3Ca3, just like here, and seawater, that means seawater contains 2.5% NaCl, and sylvine, this is KCl. So all these are what? Minerals of 17th group elements. Next important point, among these elements astatine is the radioactive element, that means it is more reactive. Next one, general properties. We know general properties. What are the general properties? Atomic size, IP, En, Ea, these are the general properties. First property, atomic size. We know that from top to bottom atomic size increases due to increasing number of shells, thereby iodine having more atomic size and fluorine having less atomic size, so that its order is F less than Cl less than Br less than I. Next, IP. When atomic size increases, IP decreases. Both are having inverse relation, so that F is having more IP and iodine having less IP. Next, electronegativity. Electronegativity also having same nature as IP with atomic size. That means it is inverse relation with the atomic size. So fluorine having more electronegativity, thereby iodine having less electronegativity. Not only in this group, among all periodic elements, fluorine having more electronegativity. Next important order is EA, electron affinity. This is also called electron gain enthalpy. This is also actually inversely relation to atomic size, so that iodine having less electron affinity, and fluorine should have more electron affinity, but chlorine having more electron affinity. This is very important question. So why fluorine having less electron affinity than chlorine? This is very important 1 mark question. For that, 2 reasons are there. First one is due to small size, and the second one is stronger interelectronic repulsions in fluorine. That means compared to chlorine, fluorine having small size, and in fluorine interelectronic repulsions are more. So what? If interelectronic repulsions are more, it cannot gain electrons easily. If it cannot gain electrons easily, automatically it will be having less electron affinity. So what is the answer? Due to small size and stronger interelectronic repulsions. That means single line answer. Due to small size and stronger interelectronic repulsions, Fluorine having less Ea than Cl. Next, atomicity. Atomicity means how many number of atoms present in a substance. All elements are diatomic. That means all contains two atoms. F2, Cl2, Br2, I2, like that. Here we didn't discuss about acetylene because it is radioactive element. Next, metallic and non-metallic nature. Metallic means all are non-metals. All are non-metals. That means they have tendency to gain the electrons. Next, physical state. Fluorine, chlorine are gases in state. Bromine is liquid in state, and iodine is gas in state. That means all types of element. All types means all type of matter, solids, liquids, gases exist in this group only in the periodic table. This is very important bit. All type of matter exist in which period, which group in the periodic table? 17th group. Fluorine, chlorine are gases in state. Bromine is in liquid state, and iodine is iodine here is solid, not gas. Just correct it. Here iodine in solid state, not in gaseous state. Next one, color. All these elements exhibit color because they absorb radiation in visible region. Then the electron jumps from pi star 2px or pi star 2py orbital to sigma star 2px orbital. I repeat once again. All these elements exhibit color. Why? Because they absorb radiation in visible region, so that the electrons jumps from, these are molecular orbitals. We discussed all these topics in chemical bonding chapter. So that the unpaired electrons present in these orbitals can jumps to this orbital, automatically they exhibit colors. Fluorine having yellow color, chlorine having green yellow color, greenish yellow color, bromine reddish brown, and iodine violet color. These are the colors exhibited by respective elements. Next, SRP, nothing but standard reduction potential. Standard reduction potential or oxidizing power. Standard reduction potential or oxidizing power. So all these elements having more SRP values compared to other elements. Reduction potential means what? The tendency to gain the electrons. That is also called oxidizing power. So these are having more SRP values. That means automatically they are having more oxidizing power. Due to high oxidizing power, they can oxidize other substances. Among the elements, fluorine has more SRP value, so that it is the more SRP element or more oxidizing power than any other element in the periodic table. So F2 can oxidize, it can oxidize Cl minus, Br minus, iodide to Cl2, Br2, I2. Because fluorine having more SRP value, nothing but fluorine having more oxidizing power, so that it can oxidize Cl minus to Cl2 and Br minus to Br2 and I minus to I2. These are the respective equations. How can we consider these are the oxidizing equations? Because see, here Cl having -1 oxidation state, but here Cl2 having 0 oxidation state. That means from here to here oxidation state increases. That means fluorine gains electrons from this substance. That means fluorine acts as oxidizing agent. Here also fluorine can oxidize Br minus to Br2. Fluorine can oxidize iodide to iodine. Next, Cl2 can oxidize Br minus, I minus to Br2, I2, because after fluorine, chlorine having more oxidizing power. That is why it can oxidize bromide to bromine and iodide to iodine, but not fluoride to fluorine, because compared to chlorine, fluorine having more oxidizing power. So these are the respective equations regarding this one. And the last one, that is what? Bromine. Bromine can oxidize iodide to iodine, but not oxidize fluorine, fluoride to fluorine, chloride to chlorine, because compared to bromine, fluorine and chlorine having more oxidizing power. So this is the respective equation regarding this one. Next one, oxidation states. The common oxidation state of halogens is -1. That is the common oxidation state of halogens. Fluorine shows zero oxidation state in elementary form. Not only fluorine, every element shows zero oxidation state in its elementary form. So how many oxidation states exhibited by fluorine? 2. One is 0 and one more is -1. Here one important question is there, that is, what is the highest oxidation state exhibited by fluorine? What is the answer for that? 0. Because 0 is the more value compared to -1. Next, other elements, chlorine, bromine, iodine, they shows +1, +3, +4 and +7 in addition to -1. That means they exhibit different oxidation states along with -1. So this is about oxidation states of fluorine. Next, among all halogens, fluorine has high reactivity because of high electronegativity. That is why fluorine is called superhalogen. Why fluorine is called superhalogen? Because of its high reactivity. Why it is having high reactivity? Because of high electronegativity. Next, there are some more points regarding that one. Reactivity regarding halogens. Reactivity, which is more reactivity? Fluorine. After that, chlorine. After that, bromine. After that, iodine. So that fluorine is much greater than fluorine, greater than bromine, greater than iodine. Next, bond length. Bond length. How can we say that? I told you already in previous videos. From top to bottom, atomic size increases. If atomic size increases, then those atoms forms longer bonds. Automatically bond length will be more. Then bond energy will be less. So among this one, which is more size, iodine is more size. Automatically it forms longer bond length. So iodine having more bond length and fluorine having less bond length. So that its final order is what? F2 less than Cl2 less than Br2 less than I2. Next, bond energy. This is also called bond dissociation energy. We know that between bond length and bond energy, inversely relation. So here iodine having more bond length, automatically it will be having less bond energy. That is correct. But here, which is having more less bond length, fluorine having more bond length. Fluorine having less bond length. So automatically it should have more bond energy, but chlorine having more bond energy. This is very important question. Why fluorine has less bond energy? Why fluorine has less bond energy? Because in fluorine, it means in F2, two fluorine atoms are there. Their bond length is very less. Each fluorine having lone pair of electrons. Between lone pair of electrons, between lone pair of one fluorine and lone pair of another fluorine atom, repulsions occurs. Because of repulsions, those two fluorine atoms far apart from each other. They far apart from each other. So automatically bond energy will be less. When they far apart from each other, the bond energy will be less. So that fluorine having less bond energy compared to chlorine. So chlorine having more bond energy. So what is the answer? Fluorine has less bond energy because of its less size and repulsions between lone pair of electrons. That means lone pair of one fluorine and lone pair of other fluorine. So this is very important question for 1 mark. Next, chemical properties. With hydrogen, when these halogens reacts with hydrogen, they form MH type of compounds. In 15th group, MH3. In 16th group, MH2. Here, MH. And halogens reacts with hydrogen, they form MH type of compounds. For example, HF, HCl, HBr, HI, like that. Now here we have to discuss about some orders. Bond length, bond energy, acidic nature, boiling point. HF. Among hydrides, the bond length is more, in which case HI, because iodine is large size atom, it can form longer bond, and fluorine is small size, so it can form smaller bond. So that bond length order will be HF less than HCl less than HBr less than HI. Then what about bond energy? bond energy is inversely proportional to bond length. So HF having automatically more bond energy and HA having automatically less bond energy. Here HF is having more bond energy. Don't think like that here, because here FF, here halogens F2 is present, F2Cl. Here HF is present. Here repulsions are not there. Here also repulsions are there, but compared to here repulsions are very less. So that don't think like that. Here what we have discussed between fluorine lone pair repulsions are there. Automatically two atoms apart from each other, so that it will be having less bond energy. But here don't think like that. Here hydrogen and fluorine is there, so that here repulsions are very less between hydrogen and fluorine atom. So automatically bond length will be same as we expected. Then automatically it will be having more bond energy compared to others. So what is the order? HF greater than HCl, greater than HBr, greater than HA. What is this order regarding bond energy? Next, A means acidic nature. This is very important order. Acidic nature means tendency to liberate hydrogen. When it is easily liberate hydrogen, when bond length will be more, automatically acidic nature will be more. In which case bond length will be more? In this case automatically it will lose hydrogen easily. Automatically it is having more acidic nature. It is having less acidic nature because of less bond length. So what is the order? Same order as in bond length. Next, boiling point. We know that what boiling point depends on two factors. One is molecular weight and one more is hydrogen bonds. Actually, as per molecular weight, it should have more molecular weight. Which one? HI. Because HI having more molecular weight, so that automatically it should have more boiling point. But HF exhibits more boiling point because of hydrogen bond. So because of tendency of hydrogen bonding exhibited by HF having more boiling point. After that HA, then HBr, then HCl. Why HF exhibits more boiling point compared to HA? HF exhibits hydrogen bond, so that it is having more boiling point. So this is about hydrides of 17th group elements. Next one, with oxygen. That means when these elements react with oxygen, what happens? See, in case of fluorine, when fluorine reacts with oxygen, it can form two types of oxides. One is OF2 and one more is O2F2. OF2 and O2F2. Both OF2 and O2F2 act as oxidizing agents and fluorinating agents. That means oxidizing agents means when these compounds react with other substances, they liberate oxygens as well as fluorines. That is why these are called oxidizing agents as well as fluorinating agents. Next, O2F2 is used to remove plutonium. Pu means plutonium as PuF6 in nuclear reactions. That means when any compound containing plutonium, when that compound reacts with O2F2, then that plutonium will be removed as PuF6 in nuclear reactions. Next, when chlorine reacts with oxygen, it can form four types of oxides. They are Cl2O, ClO2, Cl2O6, Cl2O7. ClO2 acts as oxidizing agent. That means it readily liberates oxygens when it reacts with other substance and used for bleaching wood pulp and sterilizing water. Next, when bromine reacts with oxygen, it can form three types of oxides. They are BRO, BRO2, BRO3. All these oxides are highly oxidizing in nature and highly unstable because of more reactivity, and can exist in only at a low temperature. These are more oxidizing in nature and more unstable, and they exist at low temperatures only. Next, about iodine. When this iodine reacts with oxygen, it can form three types of oxides. They are I2O4, I2O5 and I2O7. These are insoluble solids and decompose on heating. That means these are also unstable. Next one, regarding this I2O5, it is very good oxidizing agent and is used in the estimation of CO. That means when I2O5 reacts with CO, it can determine the amount of CO. That is the meaning of estimation of CO. So this is all about chemical properties of 17th group elements with oxygen, hydrogen. Next one, with halogens. That means when these elements reacts with other halogens, when halogens reacts with each other, that means here reaction taking place between two halogens, two different halogens. When halogens reacts with each other, then interhalogen compounds are formed. Interhalogen compounds means compounds contain two different halogens. These are four types. That means there is a chance of four types of compounds. They are XX dash, XX3 dash, XX5 dash, and XX7 dash, where X is larger halogen atom and X dash is smaller halogen atom. X is larger halogen and X dash is smaller halogen atom. And separately we have to discuss about this topic because this is very important topic in this chapter. Next property, with metals. That means when 17th group elements reacts with metals, they form halides. It forms halides. For example, when sodium metal reacts with chlorine, then we get sodium chloride, NaCl. And one more example, when magnesium metal reacts with bromine, Br2, then we get MgBr2. So these are what halides. Next, here one more important point is that is according to Fajans rules, as the charge on the ion increases, covalent character increases. As the charge on the ion decreases, ion character increases. We know already all these points because we discussed already these points in chemical bonding chapter. Sometimes some compounds will be given, write the question may be write the covalent character order or write the ionic character order. For example, take these three compounds, NaCl, MgCl2, AlCl3. Among these three compounds, which is having more covalent character? AlCl3 having more covalent character. Why? Because in AlCl3, Al having plus 3. In MgCl2, Mg having plus 2. In NaCl, Na having plus 1. So as the charge on the ion increases, covalent character increases. So that AlCl3 having more covalent compared to MgCl2, and which is more covalent compared to NaCl. But in case of ionic character, it is exactly opposite to the above character, because what is the condition for ionic character? As the charge on the ion decreases, ionic character increases. In case of NaCl, Na having plus 1, MgCl2, Mg having plus 2, AlCl3, Al having plus 3. In which case charge is less? In this case charge is less. If charge is less, automatically ionic character will be more. So that NaCl having more ionic than MgCl2, which is having more ionic than AlCl3. So all these are what chemical properties of 17th group elements with oxygen, hydrogen, halogens and metals.